All right, let me have that recorded. All right, so binomial theorem is really the expansion of if you had a quad or what if you had like y equals and then you had parentheses with some power. That's what binomial expansion is. We care about more the fact of combinations because that's what you're generally asked about. And when we talk about combinations, we also usually talk about permutations, but that's not going to happen today. We're strictly just talking about combinations. So the notation for that is NCR. If you're in your calculator, you would type in this number first, and then there's an option in some of the calculators. You can just use this, and it allows you to plug in here and here. If you're in a lower model calculator, you put in the number, hit combination, put in this number, and then hit enter. It just depends on which calculator that you're using. And that's equal to n factorial all over n minus r factorial. Sorry, there's supposed to be a factorial here too. Is that size good for everybody? Can everybody see that pretty well, or do I need to write larger?
I can see it.
Okay.
Yeah, it's good.
Okay. So this is your formula every time. It doesn't change. This is a pretty straightforward process. So if they say find each binomial coefficient, they have things like for A, if you had 8, C, and 2. All right. All you're doing is saying, hey, that's 8 factorial all over 8 minus 2 factorial 2 factorial. And then you're working it out. We talked about factorial problems last week. This is as simple as doing 8 factorial over 6 factorial 2 factorial. If you remember, this is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. I can get rid of everything after 6 and after. So really I have 8 times 7 over 2. So I get 56 over 2, which is just 28. All right, so this should be pretty straightforward. Like it's this plug and chug. There's nothing crazy difficult about this. You can do the same thing for, if I give another problem, if you have, sometimes they're written like this. They're written as 10, 3. If they're written in this way, please know that this is the same thing as 10, C, 3 for combination. All right, and then you go through and solve it just like you did with this problem. So if you want, I'll give you all a second to work on that. And I'll work it out on my screen. Yay. All right, hopefully you got 120. All right, you have 10 factorial over 7 factorial times 3 factorial because 10 minus 3 is 7. And then you just work it out. So 10 times 9 times 8 over 3 times 2. I went ahead and just canceled the fractions. So I came in at this point and said this will cancel, leave me a 3. This will cancel, that leave me 4. And 3 times 4 is 12 times 10 is 120. All right, so nothing super crazy there. To go along with this, you have what's known as Pascal's triangle. And Pascal's triangle is actually a breakdown of how to deal with binomials to different powers. So if you have Pascal's triangle, it's literally the following. You have x plus y to the 0 power, x plus y to the 1 power, x plus y to 2 power x plus y to the 3 power plus y to the 4th. All right, and we'll be hopefully we understand the pattern after that. All right, so you have here you have 1 because anything to the 0 power is 1. Then you have 1 and 1. All right, then you have 1 on the outside, 1 on the outside, but 1 plus 1 is 2. And then you have 1, 3, 3, 1. Then you have 1, 4, 6, 4, 1. All right, 1's always on the outside, but then you have like 1 and 1, and you have a middle term that's 2. Then you have 1, and then 1 plus 2 is 3. 1 plus 2 is 3, 1. Then you have 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, 1. And that repeats every single time. What's really happening here is if you're using binomials, that you have x, y with a plus. And then you have x squared plus xy plus y squared. And then you have x cubed plus x squared y plus xy squared plus y cubed. All right, you kind of get the point. And that works its way down. So anytime you had an x and y value to a certain power, you could just use this and be able to figure it out. It'd work every time. I always show that because that's a useful thing if you're doing any type of binomial expansion, especially on like ACT. You could use that pattern. But beyond that, I don't test over that specifically. It's just a useful tool that you have that you can use. Is there any questions over that?
So we just put like a number for the x and y and do it, or is that just
yeah, basically. Okay. Like in the sense of like if you had
it was like if it was like 2 plus 4 in like the parentheses to the 4th, you could just like work it out.
Well, if you had 2x plus y to the 4th, you could use this pattern. You just need to know that the 2 would impact all the x terms.
Okay.
Or all the it would impact by multiplying through, if that makes sense.
Yeah. All right.
My bigger concern is you guys being able to do combinations because those show up on the ACT and that's what's on your final. More so than Pascal's triangle. If there's no other questions, that's literally what today's lesson was, is just combinations in Pascal's triangle. It was short, easy, and to the point. Okay. I'll upload the